SpaceX just revealed the secret behind Dragon's touchscreen cockpit. 3 giant screens replaced hundreds of switches. But here's the twist. Many experts doubted it could ever work in space. The old space shuttle had 3,000 switches. One wrong touch, and astronauts could make things worse. So why did SpaceX bet on glass instead? And why do astronauts now refuse to fly anything else? Stay with me. The answer changes everything you know about spaceflight. Let's go back to 2014. NASA had a problem. The space shuttle was retired. Every astronaut heading to the International Space Station had to buy a seat on a Russian Soyuz rocket. One seat. Reportedly over $70 million. NASA needed its own ride again, and it needed 2 companies to build it. So if one failed, the other could still fly. 2 companies stepped up. Boeing, with over 100 years of aerospace history behind it, and SpaceX, a company that was only 12 years old at the time. On paper, this wasn't close. Boeing had built the 747. Boeing had built pieces of the space shuttle itself. SpaceX had built rockets that kept blowing up in its early years, and one small cargo capsule. But here's the detail most people miss. That small cargo capsule had already done something no private company had ever done before. In 2012, SpaceX's Dragon became the first commercial spacecraft in history to dock with the International Space Station. Over the next 2 years, it flew multiple cargo runs, and it did something the competition couldn't. It survived re-entry and came home intact, instead of burning up like most cargo vehicles. So NASA made its bet. Both companies got contracts. Boeing received about $4.1 billion to build Starliner. SpaceX received about $2.6 billion to build Crew Dragon, $1.5 billion less, largely because SpaceX was upgrading a spacecraft it already had, instead of starting from a blank sheet of paper. Same goal, same deadline, same destination, 2 completely different machines. And the difference wasn't just the price tag. It was philosophy. Walk into Starliner and you're greeted by hundreds of physical switches and dedicated control panels, a cockpit that would feel instantly familiar to any space shuttle pilot. Walk into Crew Dragon and you're greeted by 3 touchscreens and almost nothing else. One capsule was built to feel familiar. The other was built to feel like nothing that had ever flown before. Only one of those choices would end up defining the future of spaceflight. So which one and why? 2 philosophies, 1 problem. To understand why SpaceX made such a radical choice, you have to understand what a capsule interior is actually fighting against. Space is small. Every capsule is a sealed can with a fixed amount of usable air inside it, and every inch that gets eaten up by hardware is an inch an astronaut doesn't have to move, work, or simply breathe comfortably for days at a time. Starliner's shape is a direct descendant of the Apollo capsule, just scaled up. A wide cone, tapering walls, a shape that looks generous on a technical drawing. But here's the catch. In microgravity, those sloped outer walls aren't very useful. You can't float comfortably against an angled surface the way you can float in open space. So, a lot of that extra volume on paper turns into wasted volume in practice. Crew Dragon took a different approach to the geometry itself. Its cabin is taller, more vertical, and it concentrates the open space near the center of the capsule, rather than spreading it out toward the sloped edges. That's not a small design choice. It's the difference between a room shaped like a tent and a room shaped like a tower. One traps usable space along the walls. The other stacks it in the middle, where a human body can actually use it. But geometry was only the first battle. The second, bigger battle was the control panel itself. Think about the difference between an old car dashboard from the 1980s, covered in dozens of identical black buttons, and a modern electric vehicle with one clean touchscreen. The old dashboard needs you to already know exactly where every button is, because none of them explain themselves. The new screen can show you exactly what you need, exactly when you need it, and hide everything else. That's the exact bet SpaceX made with Dragon. Starliner's cockpit, like the shuttle before it, is covered in dedicated hardware. Every function gets its own switch, its own light, its own dedicated piece of real estate. It works, and pilots trust it, but it also means the cockpit is permanently cluttered with controls for systems you might use once in an entire mission. SpaceX replaced almost all of that with 3 screens that change based on what phase of the mission you're in. During launch, the screens show launch data. During docking, they show docking data. The same physical space does 10 different jobs instead of one job forever. It's a smaller cockpit that somehow feels bigger because it isn't fighting you for space anymore. Sounds elegant. Sounds obviously better, right? Except this is exactly where NASA started to get nervous. Because a touchscreen has a problem that a mechanical switch simply doesn't have. The glass problem no one could ignore. Here's the part most retellings of this story skip entirely, and it's the part that almost sank SpaceX's entire design. Think about what actually happens during a rocket launch. You're being shaken violently. You're being pushed back into your seat with several times the force of gravity. Your hands, your arms, your entire body are fighting the vibration just to stay in one place. Now try to tap a precise button on a piece of glass under those conditions. A physical switch has a guard around it and requires deliberate tactile pressure. You feel it click. You know it engaged, even without looking. A touchscreen has none of that built in. Under heavy vibration, a fingertip can slide right off the intended button and land on the wrong one, and unlike a mechanical switch, the glass gives you no physical confirmation that anything even happened. This is the exact reason so many aerospace veterans doubted the idea from the start. Most NASA astronauts came from military aviation or commercial airlines, professions built entirely around physical flight decks. Asking them to trust their lives to touchscreens during an emergency abort wasn't a small ask. It was a direct challenge to decades of aviation culture. So what did SpaceX actually do about it? Not abandon the idea. Engineer around the weakness, piece by piece. First, the gloves. Astronaut pressure suits normally aren't built to interact with touchscreens at all because the fingertips are sealed and insulated. SpaceX had to weave conductive material directly into the fingertips of the suit, so a fully suited astronaut, hands sealed inside pressurized gloves, could still register a precise touch on the display. Second, the hardware around the screens. Underneath each display, SpaceX built curved handholds specifically so an astronaut could physically brace their entire hand against the panel during launch, an abort, or violent vibration, turning an unstable target into something they could anchor themselves against before touching it. Third, and this is the detail people almost always leave out, SpaceX never actually deleted physical switches completely. Hidden beneath the center display sits a small panel of essential mechanical switches, reserved only for the functions that absolutely must work under any circumstance, no matter what the software is doing. Everything routine goes to the touchscreen. Everything critical and time-sensitive still has a guarded physical backup. That's not a company blindly chasing a futuristic look. That's a company identifying the exact failure point of its own idea and building a specific physical fix for it. And then came the part software alone could never solve: training the humans. NASA astronauts Doug Hurley and Bob Behnken didn't just show up on launch day and hope for the best. They worked directly with SpaceX's engineers for years, testing and adjusting the touch sensitivity, the menu layouts, even the exact size and placement of on-screen buttons, until the interface could be operated quickly and correctly under real mission stress. Then came hundreds of hours in full-scale simulators, cabin depressurization drills, display blackout drills, manual flight scenarios practiced over and over until reaching the right function on the right screen stopped being a conscious decision and became muscle memory. The same way an experienced typist doesn't look at the keyboard anymore. By the time Hurley and Behnken actually strapped into Dragon for real, the touchscreen wasn't an experiment anymore. It was a trained reflex. But even after all of that, one question remained. If the whole point of a touchscreen cockpit is speed and simplicity, why train astronauts this hard to use it at all? And that question leads to the real secret of Dragon's design, the one that has almost nothing to do with the screens themselves. The spacecraft that flies itself. Here's the twist: most people never hear about this story. The touchscreens were never really the point. Every earlier American spacecraft, from Apollo to the space shuttle, put the human at the center of nearly every critical maneuver. The pilot flew it. The pilot docked it. The pilot brought it home. Even Russia's Soyuz still leans heavily on the crew for major phases of flight. Crew Dragon quietly flipped that entire relationship. During the approach to the International Space Station, Dragon's onboard computer takes over almost the whole job. Cameras, GPS receivers, and navigation sensors continuously track the capsule's exact position and speed relative to the station. The flight computer processes all of that in real time and fires the Draco thrusters with a level of precision that a human hand simply cannot replicate. Dozens of tiny corrections a second, far smaller and far more frequent than manual piloting would allow. Coming home works the same way. After leaving orbit, Dragon manages its own orientation, controls its own descent, and executes the entire splashdown sequence, almost entirely without the crew touching a control. Think of it less like a car you drive, and more like a modern airliner on autopilot, where the pilots aren't gripping the controls for 8 straight hours. They're watching the instruments, ready to take over the instant something looks wrong, but the aircraft is doing the actual flying. That's the real relationship SpaceX built between astronaut and spacecraft. Not operator, but supervisor. The crew's job shifted from constantly flying the vehicle to monitoring its health and stepping in only when something goes wrong. And this is where Bob Behnken's own words say more than any marketing material ever could. Talking about the old space shuttle, the vehicle he trained on for years, he put it simply: there were about 3,000 switches inside that cockpit, and there was no situation astronauts couldn't make worse by touching the wrong one at the wrong time. When Dragon came along, he said, the crew was grateful the next vehicle they'd fly on would be a little more automated. Read that quote again. That's not a rookie complaining about old hardware. That's a veteran pilot, someone who had flown the most complex switch-heavy cockpit in American history, essentially admitting that more manual control wasn't always safer. Sometimes it was just more ways to make a mistake. The historic Demo 2 mission proved this in practice. Hurley and Behnken did fly Dragon manually, but only briefly, and only to confirm the backup controls actually worked as designed. Under completely normal conditions, the spacecraft would have completed the entire mission on autopilot, start to finish, with the humans simply along for the ride, ready to intervene. Even mission control fits into this new hierarchy differently. Engineers on the ground can often diagnose a problem remotely and upload a fix directly to the spacecraft's computer without the crew ever touching a switch. Manual piloting isn't the primary method of flying Dragon anymore. It's the final layer of redundancy, the last line of defense if every automated system somehow fails at once. So the touchscreens were never really about looking modern. They were the visible surface of a much bigger decision. Software flies the spacecraft, and humans exist to catch what software can't. Starliner, notably, was also designed with autonomous capability. Boeing didn't ignore automation entirely, but Boeing kept a cockpit filled with far more physical switches and dedicated manual interfaces, staying closer to the old philosophy of keeping the human hands-on by default, rather than hands-off by default. 2 spacecraft, both capable of flying themselves. Only one company fully committed to that idea, top to bottom, all the way into the cockpit layout itself. And that single difference in philosophy is exactly what separated these 2 programs once both of them actually had to fly. When the gamble paid off and when it didn't. By 2020, the bet was settled, at least for one side. Crew Dragon carried Hurley and Behnken to the International Space Station, becoming the first privately developed spacecraft in history to carry humans into orbit. That single flight ended nearly a decade of American dependence on Russian Soyuz seats. Since then, Dragon hasn't just flown once. It has become one of the most reliable crewed spacecraft systems ever built, flying mission after mission without a single catastrophic failure. Starliner's story went the other way. The program was delayed for years by software errors and hardware problems. When it finally carried astronauts, Butch Wilmore and Suni Williams, to the ISS for its first crewed test flight in the summer of 2024, propulsion problems struck during docking. What was supposed to be an 8-day test mission turned into something NASA had never wanted to do: send the capsule home empty and leave the astronauts behind on the station, because Starliner itself was no longer considered safe enough to bring them back. Wilmore and Williams ended up staying on the ISS for 286 days, nearly 10 months, far longer than either of them had trained for. When they finally came home, they didn't come home on Starliner. They came home on a Crew Dragon. Read that again, because it's the detail that defines this entire story. The spacecraft that was supposed to prove itself safe enough to fly astronauts ended up needing its competitor to rescue the crew it had carried up. NASA classified the incident as a Type A mishap, its most serious safety designation. And that brings us to the part of this story that most videos covering this topic never even get to, because it happened after almost everyone stopped paying attention. The part of the story nobody's talking about yet. Here's where this story picks up right now, in the middle of 2026, and where it takes a turn very few people outside the space industry have actually noticed. NASA's own Inspector General released an audit at the end of June 2026, examining exactly how the commercial crew program got here, and the findings weren't gentle. The report states plainly that Starliner will not receive human rating certification, the official approval needed to fly astronauts again until 2027 at the earliest. That's not a delay measured in months anymore. That's over a decade past the program's original target. Think about that timeline for a second. The original certification goal was 2017, then it slipped to 2019, then 2021. Now the newest projection is 2027, and even NASA's own watchdog says that date should be treated as a projection, not a promise, given the program's track record. The propulsion issues that stranded Wilmore and Williams? As of the most recent reporting, they remain unresolved. Boeing's next Starliner mission isn't even going to carry a crew. It's being planned as an uncrewed cargo flight, and as of now, it doesn't even have a confirmed launch date. Meanwhile, SpaceX isn't just still flying, it's scaling up. Crew Dragon earned its human rating certification back in 2020 and has since completed well over a dozen crewed missions to the space station, with its next rotation mission already in preparation. One company is treating crewed spaceflight as routine. The other still hasn't finished proving its spacecraft is safe enough to try again. And here's the detail that ties this entire story back to that touchscreen cockpit we started with. The International Space Station itself is currently planned for decommissioning around 2030. NASA's own auditors pointed out that with Starliner's certification possibly slipping to 2027 and the station's remaining lifespan already limited, there may only be a handful of years, maybe a few missions, for Starliner to actually do the job it was contracted for over a decade ago, before there's no station left to fly to. So ask yourself the question this story has been building toward the entire time. Was Boeing's failure really about propulsion valves and helium leaks? Or did it start much earlier than that, back at the design table? Back when one company chose to keep humans doing what humans have always done, and the other company chose to ask a harder question. What should a human actually be doing inside a spacecraft? And what should be left to the machine? Because when you strip away the touchscreens, the switches, the gloves, and the training simulators, that's really what this entire story has been about from the beginning. Not which cockpit looks more futuristic, but which company was willing to fundamentally rethink the relationship between a pilot and a vehicle, instead of just updating the same relationship with newer parts. One company built a spacecraft that trusted its crew to fly it manually, the way every spacecraft before it had. The other built a spacecraft that trusted its own software first, and its crew second, as the final safety net rather than the primary pilot. Only one of those bets has actually been tested by real missions, real emergencies, and real astronauts stranded in orbit. And the results, as of today, aren't close. That's the engineering trade-off behind Dragon's cockpit. Thanks for watching. I'm Adrian, the Space Brief. Like, share, comment your take, subscribe, and check the video on screen now.